Good afternoon, my YouTube viewers. In this video, what we're going to be discussing is how to analyze water quality ratings. And we're going to analyze the water quality ratings by writing a program in Python to do that. And so what we're going to need to do in order to write this program is we're going to need to import 3 Python libraries that are necessary to execute the program. So the first Python library that we're going to import is pandas, which is a data processing library, and it performs and it creates data frames and series. So we would import pandas as PD. And then we're going to import NumPy as NP, which is a numerical library, but it also creates NumPy arrays. And then thirdly, we're going to import matplotlib.pyplot as PLT, which is a visualization library. And after we have imported our libraries, then we need to simulate some water quality ratings data for multiple sites. So the first thing we're going to do in that regard is to set our seed, because you need to set a seed so every time you run the program, the variables will be initialized to the same value. And you set the seed by typing np.random.seed and any number you want within the brackets. And so we're going to define the variable sites, which is a list of 3 sites. And then we're going to define the variable ratings, which is a list of 4 ratings, being poor, fair, good, and excellent. So we're going to generate some random water quality ratings for each site, which is ordinal data. So data equals curly brackets, site colon np.random.choices bracket sites, comma size equals 100. So the sites is going to be a list of 3 sites, and the size equals 100 is going to be 100, a sample size of 100. And then the rating is np.random.choice brackets ratings, which is the list for ratings, comma size of 100 samples, and the probability is going to be 0.01, 0.03, 0.04, 0.02. And then so the thing about the P is the P stands for probability, and you'll notice that when you add up the 4 probabilities, they total of 1. So because it has to be a total of 100% for the 4 ratings. And then now, after we created our data, synthetic data, what we need to do is we're going to create a data frame using pandas. So df equals pd.dataframe data. So now we're going to calculate the distribution of ratings for each site. So rating distribution equals pd.crosstab brackets df site, comma df rating dot reindex columns equals ratings. So we're going to plot a bar chart of water quality ratings by site. So rating distribution dot plot brackets kind equals bar, comma fig size equals 4,6, comma stacked equals false, comma color equals red, orange, green, blue, comma alpha equals 0.75. The title is water quality ratings by site. X label is site. Y label is frequency. The legend gives you a title of rating. Then your grid is going to be AX equals Y, comma line style equals dash, comma alpha equals 0.7. PLT dot type layout, and then you're going to show the bar chart. So now you're going to make a stacked bar chart of water quality ratings by site. So rating distribution dot div brackets rating distribution dot sum brackets, axis equals 1, comma, axis equals 0, and dot plot, brackets, kind equals bar, comma, fig size equals 6, comma, 4, stacked equals 2, color equals red, orange, green, blue, and alpha equals 0.75. The title is Proportional Water Quality Ratings by Site. X label is site. Y label is proportion. The legend title is rating. The grid is axis equals Y, comma, line style equals dashes, comma, alpha equals 0.7. Then you have PLT point dot type layout, and then you have PLT dot show. So now we've got two charts that we have created. The first is a bar chart that is not stacked, and it says water quality ratings by site. So red is poor, orange is fair, green is good, and blue is excellent. So you've got ratings of A, B, C, or you've got sites of A, B, C, sites of A, B, C. So you'll see that poor appears the least in number B, and excellent appears the least in number A, and fair appears the most in number C, and good appears the most in number B. So that just helps you to analyze the water ratings. And now we have the proportional water ratings by site, and the bars are stacked. So when the bars are stacked, you're able to see which ones have the least poor rating, which is B, which ones has the least fair rating, which is orange, which one has the least good rating, which is C, and which one has the least excellent rating, which is A. So that just helps you to analyze the water ratings in a different way. So that concludes this video. I believe this is the last video we have in non-parametric test. And the next section of videos that we're going to have is going to be A/B testing. So I hope you watch my set of videos on A/B testing as well.